Math 188 Research Presentation. Knot theory is a branch of mathematics that falls under the topology umbrella. Two simple questions that knot theory has evolved to answer are, is this knot actually a knot, and is this knot the same as that knot? Mathematicians have spent centuries developing the most efficient methods of answering those two questions. Other than the pure mathematical side of things, knot theory has applications in other disciplines such as biology and physics. Knots have been used to study atoms, electricity, and magnetism, and are still used to study DNA. In 1794, German mathematician and physicist Carl Friedrich Gauss created the first method of knot tabulation. He labeled the crossings with a sequence of letters and called it the scheme of the knot. He also created the first link invariant, the Gauss linking number, which is used to determine the equivalence of knots.
William Thomson, or Lord Kelvin, had a theory that all matter was composed of vortex atoms, three-dimensional knots made of ether. He proposed that atoms could be identified by the knots that they resembled, and that molecules were intertwined vortex atoms. This theory was rejected, however, around 1872, when the periodic table was published. James Clerk Maxwell was drawn to knot theory through the study of electricity and magnetism. He used Gauss's knot tabulation and created knot diagrams that specified over and under crossings. He also defined three Reidemeister moves that would be proven and named in the 1920s. Despite his achievements, Maxwell never submitted his papers, and it wasn't until over a century later that they were published. Peter Tait's exploration into knots produced an official published table of alternating knots with up to 10 crossings. He also defined a nugatory crossing, a crossing that could be added or removed with a twist. This would later be called the first Reidemeister move. Polynomials truly began with Emil Artin's braid theory that James Alexander linked to knots in 1923, when he proved that every knot can be represented as a closed braid. By 1928, Alexander had created a polynomial knot invariant that could perform previously impossible computations and distinguish non-isotopic knots from one another. His polynomial is obtained through matrices.
In the 1920s, Kurt Reidemeister proved that only three operations are needed to show the equivalence of two knots: twisting and untwisting, moving a loop over another, and moving a string under or over a crossing. Another more complete polynomial was created by John Conway in the 1960s. Then, in 1984, Vaughan Jones finished the job with a method that created a unique polynomial for every knot. Viktor Vassiliev, a Russian mathematician, applied his expertise in catastrophe theory to the world of knots and invented the Vassiliev invariants, which incorporate all the previous polynomial invariants. Knot theory is currently being used to improve the algebraic eraser, a crypto system that combines knots with encryption keys.